What is up, everybody? Today we are going to be talking about all things electrical. When it comes to your off-grid Skoolie or van conversions, this is part one of two that will hopefully give you guys all the information you need on starting these systems. Stay tuned. Hi there, and welcome to Healthy Trails. I'm Steven.
And I'm Jackie, and together we created Healthy Trails to bring wellness to you.
We're traveling around the U.S. in our self-converted school bus and home on wheels to meet you where you're at and help guide you along your individual wellness journey. We can't wait to explore and adventure with you as we navigate together towards a happier and healthier life. All right, welcome y'all. Today we're going to be talking about a very daunting topic, at least it was for me in this conversion process starting off, and that is electrical. So as someone who knew next to nothing coming in, was completely blind, I get how challenging this part of the build is. And this video is basically designed to hopefully be a resource to my former self, someone who is coming in with completely no knowledge. And between this video and the next, hopefully giving you guys the tools that you need, the information, the resources that you need to be able to start building that off-grid electrical system. So part one, this video is going to be talking about the basics, what all the components are, what they do in the system, if you need them in your system, and how they're generally wired. In part two, we will get into much more of the nitty-gritty details, sizing out the individual components of your system. How big a battery bank do you need? What do the fuses look like? How big of a solar array? All that stuff that trips up a lot of people, myself included, and was completely over my head starting off this whole process. So it's my hope that then after these two videos, you at least have a good place to start in building that off-grid electrical system. With that, we'll get right into it. So to give you guys a little bit of a better gauge on how to set the system up, what it looks like on the macro scale, I did go ahead and create this electrical schematic. My apologies for how messy this is, but when compared to the actual electrical system, it's probably a little bit easier to understand, although I will try to go back and forth between the two to give you guys both views on that, on how it's wired on our system, how it's theoretically wired if you were to do it yourself as well. All right, so beginning with the components, we'll start with probably the most basic component, and that is just your battery bank. I'm going to assume for the purposes of this video that we are running with the 12 volt options, a 12 volt battery. I will talk much more in detail about picking the right batteries in part two. But for this purpose, we will just be talking about those battery banks, assuming you've got 12 volt batteries and they are wired in parallel to create that 12 volt system. Now, with your batteries, in order to actually use these off grid, you will absolutely need to be able to charge them, right? As the batteries just store that energy to be used later. So we actually have three ways that we charge our battery bank. And most commonly, those three ways are A, from the vehicle or from the alternator using an isolator voltage sensitive relay. At least that's what we use on ours, which is connected back to our starter battery, which allows us to charge from the alternator as the engine is running, as the actual bus engine is running. The second way is a battery charger, which is going to allow us to charge from shore power hookups or any external AC power source that we're plugged into. That could also mean a generator as well. And then the third way is just our solar panels, which is going to basically allow us to charge from the sun, right? Now, in order to charge from the sun, you are also going to need a charge controller. And that is basically just going to regulate how much power is being directed back into those 12 volt batteries. And those are basically just the three ways then that we can charge the batteries. But in order for those batteries to be effective and useful in our off-grid system, we also need a way to be able to utilize that power from the batteries. So there are a few basic pieces of information that you're going to have to know going into this as well. And that is what type of power you're planning on using. The two types being AC and DC power. You might be familiar with this, right? So DC is direct current. That's going to be your 12 volt power with a positive and negative lead that complete that circuit back to the battery. The AC system, or your AC power, is alternating current. And this is basically your typical household power, right? Anything with a 2 or 3 pronged outlet that you're going to use in your house, that will be AC powered. So for the 12 volt power, in the diagram, those are going to be denoted by any of the black and red wires. Red being positive, black being negative. Practically speaking, these wires are exactly the same. There's nothing different about them, but it helps you in the wiring process to know where they should be going. So that's basically the 12 volt wiring system that we have here. And if you are planning on using a lot of the 12 volt DC appliances, technically you can run those straight from the battery. You absolutely shouldn't. So you are absolutely going to want some form of a 12 volt fuse block between that appliance and your 12 volt battery. That's going to just help protect that appliance in case there was some issue within your electrical system, short circuit or whatever, that at least that fuse is what's going to be broken and not your appliance itself. It's also probably important to note that if you are utilizing 12 volt appliances, this is going to be a lot more efficient than running your AC typical household appliances, because it doesn't have to be converted. That power source, it stays at 12 volt. We'll talk about that next, but if you can utilize as many of those 12 volt fans, pumps, lights, etc., that's going to be a really good idea. And so if you are trying to run any AC appliances with your system, it does get just a little bit more confusing, a little bit more complicated, really just one extra step. So you can see in my diagram, the AC wiring is denoted by the green lines, and that is a different type of wire than the typical copper 12 volt wire is, and we'll talk more about that probably in video 2. But for the purposes of this video right now, just know that that is a little bit different. Instead of being 12 volt, like your 12 volt batteries, household appliances are going to be 110 to 120. There's actually no standard in the US. So when you hear these numbers used interchangeably, it's basically the same thing. Something between 110 to 120 volts is going to be your AC power. Basically, it doesn't matter. For our purposes, these two numbers can be the same. And in order to utilize your 12 volt battery bank to power these 110 to 120 volt appliances, they need to be converted from that DC power to AC, and you do this by way of an inverter. And one of the last major components that we have on our electrical system is going to be the transfer switch. And this is something that you'll need if you plan on using multiple sources of AC power coming in. So for our electrical setup, you can see we've got a shore power, which is any external AC power coming into your rig. So if you're hooked up to an RV, shore power, if you have a generator, anything that you're plugging into, you could be even plugging into your friend's house in the driveway. This is going to be something that you would use your shore power for. The other way that we get AC power, I've already talked about, the inverter, which is going to convert that 12 volt power from our battery bank. Now, if we have both of these coming in and both going to our AC outlets, we want to be able to prioritize the shore power so that we're not utilizing our 12 volt battery bank when we don't have to be. We can turn our inverter off. It's more efficient. So this transfer switch will then automatically switch to prioritize that AC shore power. And then when we're off grid, it can sense that. It will switch back so that we can use that inverter to power those AC outlets instead. We also have a battery monitor so that we can view our power consumption and how much we're charging, which I find super useful as well. And you'll also definitely want individual switches to turn off specific components of your electrical system. So for example, if you were to work on the solar panels, you'd want to be able to cut off power from those solar panels. You also might want to be able to turn off power from the alternator charging when you're already full. So you want some form of switches. Now you also are going to want individual fuses or breakers in between the battery bank and your individual components. So if something would go wrong for your system, for example, then that breaker would switch and that you aren't blowing up your whole system. Now we chose to feed two birds with one scone, so to speak, and we went with breaker switches that could actually be manually switched on or off, but also worked as those sort of fuses where if it was overpowered, it would trip and kind of was a dual purpose thing. So I would recommend that. I think it actually was a little bit cheaper even for us than running it with switches itself. So something to look into for sure. And now moving on, each of the components, right? The inverter, the fuse block, the battery charger, charge controller, they all need to make that complete circuit with your 12-volt battery bank. That means it needs to make a connection on both the positive and the negative terminal of that battery. But you can't reasonably put 5 different devices on one terminal. So what we have is bus bars, positive and negative bus bars, which are basically just an extension of those terminals that you can connect to. So you're probably going to want those as well. And it's also going to be very important that you have some way to turn off all of the power to your system. If you're working on it, if you've got issues, whatever. So you want some form of a system switch, and you want that to be the first thing coming off of that positive terminal of the battery. So we actually have that positioned in between the positive terminal and that positive bus bar. I would definitely recommend having one of those as well. And I should also mention that there should be a terminal fuse as well. That should actually be the first thing on that positive terminal. In our case, it was a 250 amp fuse that basically protects your entire electrical system from catastrophic failure. I actually am really glad that we decided to implement this as we needed it. When we were wiring everything up together, we actually wired our breaker panel incorrectly, I think, and we blew that fuse. I was running around like crazy trying to figure out what the heck was wrong with our system, and found that we actually blew that fuse. We were able to go back in, correctly wire it, put a new fuse in, and we were good. Otherwise, that could have been awful for our system. So definitely learn from my experience, implement that terminal fuse for sure to protect your system as well. In addition, first thing on the negative side before it goes to the negative bus bar, if you so choose to have a battery monitor, is going to be the shunt associated with that battery monitor as well. So you will wire that in between the two. And I think that's pretty much all of the components. I think what we'll do now then is start to zoom in on the individual pathways a little bit more and talk in a little bit more detail so you have a better understanding of how they should be wired. And to recap from the battery bank again, we have 12-volt batteries that are wired in parallel. I'll talk about why we wired those in parallel in video 2. And from there, the first thing off of the positive red terminal should be that terminal switch, that terminal fuse into your system switch, and then into the positive bus bar, which is that hub for all of your positive connections that you need to make on that positive terminal of the battery. And then off of the negative side, the negative terminal of the battery, you want that shunt if you so choose to have some form of a monitor, and that goes up to the negative bus bar. So I think we'll start talking about the solar panels and the solar charging pathway that we have on the top. And again, in video 2 of this series, we will talk a little bit more in depth about the specific configuration that we have for our solar array. But for this video, basically we can just follow the wires, and you can see that the positive and negative leads go from those solar panels through the roof entry gland. And that is basically just a method to help to weatherproof that hole that you're going to have to make in the top of your van or bus. So I would recommend purchasing one of those. The connections are made with MC4 adapters if you configure those parallel like we did. And basically you're left with that positive and negative lead that come back down. And the first thing that it's going to go to is the charge controller. However, you are going to want some form of a fuse or breaker between the charge controller and your solar panels to protect that a little bit more. So we have that on the positive lead before going into the positive of the charge controller. And then the negative goes straight down into the negative of our charge controller. And from the charge controller, it's pretty straightforward. Red to red, black to black. That is positive of the charge controller into the positive bus bar, and the negative into the negative bus bar. And that's pretty much just that whole solar pathway. If we move on next to the alternator charging, you can see that the alternator, it's not actually the alternator, it is the starter battery. So the starter battery is connected to that. And from the positive lead or the positive terminal of our starter battery, it goes up through to the VSR isolator, the voltage sensitive relay isolator inside the bus. And that isolator itself actually has 2 wires coming off of it. So the manufacturers recommend that one of these wires is grounded, and then the other one should go to the positive terminal of your household battery. So for our system, we actually needed to ground our entire electrical system. So we grounded the negative bus bar to the chassis of the vehicle. So that was effectively grounded. That way we ran the grounding wire for the VSR isolator to the negative bus bar. The positive just went into the positive bus bar, and you're good to go. All right, and then the last charging method that we have is going to be that shore power. So any external AC power generator, whatever, it comes in and goes to that transfer switch. So we actually have a outdoor all-purpose outlet, a regular AC outlet on the outside of our bus that comes into the transfer switch. The other input on that transfer switch is the inverter that get wired in from the AC output of the inverter, and the inverter itself is wired back to our battery bank by way of those positive and negative wires going back to the positive and negative bus bar, so that way that it can draw power from our 12-volt battery, take that up, convert it over to AC power. So now we have those 2 AC power sources coming into our transfer switch. And again, that transfer switch will then prioritize the shore power over the inverter power. But either way, AC power is coming into the transfer switch. AC power is going out of the transfer switch. And that goes right into our breaker panel. The breaker panel going to be wired a little bit differently than the 12-volt system. And again, we'll talk about that in part 2. But it will then go into individual breakers, from the individual breakers to individual outlets or outlet strings, depending on how you wire your AC system. And that's pretty much the AC system. Although you might be wondering at this point, we talked about how that AC power is utilized in the system, but we haven't really gotten onto how we actually charge from the shore power. We never really talked about that battery charger yet. So, what basically happens here with our system is that battery charger, it will get plugged into an outlet on our bus. So when that AC power is live, those outlets are live, it takes that power in, and then it is wired with the 12-volt wiring, the red and black wires, back to the positive and negative bus bar. So when we have shore power, that comes into the bus, through the transfer switch, to the outlets, and from those outlets, it goes through the battery charger, back to the 12-volt battery bank. So that is how we actually charge. However, this comes with a slight caveat. With our system, if we were not plugged into shore power, we would be taking that power from the 12-volt batteries through to the inverter, through to the transfer switch, to the outlets, to that battery charger. And if that battery charger was left plugged in, it would be effectively charging the 12-volt batteries with the 12-volt batteries, creating that loop, which you do not want to have. So we always leave that unplugged, but as a second precaution, we have another switch, another breaker that not only protects the device, but it also is another manual switch that we leave switched off, that when that's not connected, we won't be charging if we had accidentally left that plugged in. So if you do opt for this route, you can, by all means, should put in that extra breaker as well, or a fuse or something, at least to protect it. But that switch is just another precaution. Now, you might also use that battery charger, put it into an extension cord and take that out. In that case, you don't have to worry about it, right? You're just taking that power straight from the source. We just, however, wanted to run this with the transfer switch for efficiency's sake, so that when we were plugged into shore power, we could still use that shore power without having to use the inverter and still be able to charge the battery bank as well. So I think that pretty much sums up the AC power as far as how we use it to charge the battery bank and how we actually utilize that AC power in our outlets themselves. So jumping into the 12 volt DC power next, it's a little bit more straightforward here. You have that fuse block, which is wired back to the battery bank by way of the positive and negative bus bars, so red to red, black to black. And from there, each individual fuse is wired back to the individual appliances. We'll talk about sizing those fuses and sizing those appliances in part 2. But basically, each one of those fuses protect that appliance when you're using it. And it's pretty much simple as that. And I mean, for our purposes today, we might leave it there. Hopefully, this gives you at least a good place to start in the designing of your off-grid mobile electrical system. I'm sure I left you with questions. So things like, what gauge wire do I need? How big of an inverter do I need? How big of a battery bank do I need? What types of batteries are best? What types of inverters are best? All of this and more we will address in part 2. So make sure you check that out. You can check out the video description for any of the recommendations that I have on specific products. And we will talk about those recommendations in part 2 as well. We also have a blog page in the works where I will hopefully basically transcribe this whole video as another place that you can reference. This electrical schematic I will post as a PDF as well so that you can reference that and link a lot of those products that we either used or recommend for your electrical system. If you have anything that I missed as well that I didn't maybe say that I'll be talking about in video 2, drop in the comments. I'll try to address those best I can. And I think that's about it for today. I should note, I am not a professional electrician, right? I know some of you may be, so hop in the comments. If I missed anything, let me know. And obviously, take my word with a grain of salt. Talk with someone who maybe is that professional electrician before you go in and start wiring. And guys, best of luck on the builds.